Hello, everyone. First of all, just a few introductions. My name is Ammar Hindi, Asia Pacific Managing Director for Sonatype, and with me is Cameron Townsend, the Senior Architect. Also, we're both based in Sydney, Asia-Pac Solution Architect. So I'll get going, and again, we'll be talking to you. Feel free to ask any questions also later on via email. As you know, business applications are under continuous attack. Forrester has released some recent numbers where 51% of enterprises have suffered at least one breach in the last 12 months. 43% of these actually came from external actors, and the majority of these have been targeted web apps and using known vulnerabilities. So the work that is being done by the hackers has really been made easy in the fact that they are utilizing known vulnerabilities to attack your application. At the same time, all business, very well known fact, the business leaders out there are under attack. And we also know that since 2000, 52% of the Fortune 500 have been displaced and replaced by new by new entrants. The fact is that today's winners and today's leaders are releasing great software faster and more securely than their competitors. Essentially, we're seeing that the release cycles are getting so tight, and that a lot of companies are releasing daily rather than the usual thing of releasing monthly and quarterly. At the same time, applications are no longer written from scratch. They're being assembled using third-party components, and we've seen the rise of third-party components that are available in the open source world out there, and we'll talk about that also a bit during the presentation. This has sort of been happening throughout the past 30 years. It started all with the GNU, the release of the GNU and the Free Software Foundation in '85, and throughout the years where in the 90s Linux and JavaScript, and then the agile everything, followed by the rise of the DevOps in the few years ago, to the point right now where we have over 500 billion OSS components being consumed by the community. Writing code is, as we say, is out. Borrowing code is in. Sonatype has been part of that journey, and part of that evolving journey from the early 2000s with the Apache Maven, one of the most successful open source projects, followed by the we're still sort of the owners and the curators of the central repository, the largest Java open source repository, to also the release of the Nexus repo, the OSS version, the open source version, which is the most widely used open source repository for third-party libraries out there, in on till the release of the products and the solutions that govern and reduce the risk of open source vulnerabilities in your development lifecycle, which is what we'll be talking more about today. The Nexus Intelligence, the biggest source of intelligence on open source components out there in the market. And we continue to release things like the annual State of Software Supply Chain report, which is an annual report that we've released 4 years in a row, updating the industry and the community about the latest trends there and the facts that we have to sort of live with. All along, obviously, the point here is that we've continuously contributed to this journey and to this market over the past 20 years. That said, there's intense pressure on us to sort of deliver faster and more securely for application developers. As we said, releases and release cycles are shrinking. At the same time, the availability of open source is growing, and so you have a significantly more sources of open source that you can consume. The problem with that is that open source components are not created equally, and we say they tend to sort of age like milk, not like wine. And so invariably open source components, as they age, we'll see them become vulnerable, and vulnerabilities will be discovered that you need to then have to sort of deal with. The last 15 years have seen thousands of companies have suffered from very easily avoidable mistakes, and some of them are, I wouldn't characterize them just as mistakes, but big, massive catastrophes that cost, the privacy of millions of people to be affected, and losses in the millions and the hundreds of millions of dollars. What was the common thread with all of these, and we'll talk more about some of those things also a little bit later, is that they've all failed to manage their software supply chain. This is a typical software supply pipeline, and at any given point, bad open source components can creep into that supply chain and affect the quality of your software. And what we need to do is, what we need to talk about is a new way of managing your supply chain. So what is our software supply chain philosophy, or what are we talking about here? And our discussion here, and what we sort of talk about in Sonatype, is not new, but we feel it's very proven. We can say that this whole thing started in the early 50s with Edward Demings introducing a new way of managing supply chains in the car industry in Japan, as he was helping and rebuilding the Japanese car industry from the ruins of World War II. He helped the Japanese car industry, and the success of the Japanese car industry is attributed to him in the way he reinvented management of the supply chain. One of the same concepts that he introduced is that you need to source parts from fewer and better suppliers. The same thing we believe applies to developers, sourcing components from fewer and better suppliers of open source components. Use only the highest quality parts, use only the highest quality components, and this is very fundamental, never pass known defects downstream. Never ever pass known defects downstream. So if you know there is a component that is bad, and you have information that is readily available for you to mitigate that risk, then you shouldn't be passing those downstream. And finally, continuously track the location of every part. This is very fundamental in what we're going to be talking about today in the Sonatype philosophy, in that at any given time, you have full visibility to allow you to recall any component that you need that is now impacted by a zero-day vulnerability or whatever architectural change, that you have visibility that you can basically pull that component out with relative ease and accuracy. Not only that, but not just pull that component out, but you have the information to mitigate that and resolve that. So it changes everything that we do. In the old world, we used to use any open source. Basically, developers just wanted to get their job done. Now we embrace the highest quality of open source. We used to do a manual, quick and dirty search just to make sure that everything was okay. Now we can actually provide expert automated research at the fingertips of the developer. Okay, the best research available right there at the fingertips as developers touch open source. Security was perceived always as an obstacle to innovation. Now security is a partner in innovation. Security has to be part of the process of developing applications. Governance, again, was resisted because it was an overhead, because it slowed developers down. Now, we have to embrace governance-infused tools, and because these tools are part and parcel of the development lifecycle. And, we worried about mistakes, or we worried about, some of the checks and balances later. But now we can actually remediate mistakes as they happen. And again, going back to never pass a known vulnerability, never pass a defect downstream, because we can actually remediate this thing quite easily. And finally, the old world never really operated with existing bill of material or dashboards that allow them to see where their components are being utilized. And now we have built-in bill of materials, and everything can be audited. Everything can be basically, you can go back to and look at any build, look at any application that is in production, and see what's in it, see what open source components are being used. Again, taking a very complicated task, very cumbersome task to matter of seconds and minutes to resolve. So that's exactly why Sonatype exists, to unite software developers, security professionals, and IT operations on the same team, and empower enterprises to continuously identify or remediate open source risk. Essentially bringing the three cultures, visibility, culture, and alignment together in a DevSecOps environment. So the Nexus platform, and again we'll go back to the software development pipeline that we talked about earlier, and we have the first component. We have the Nexus firewall, and essentially the Nexus firewall automatically stops risk from entering your software development lifecycle. So at the point of components are coming from the outside into your development pipeline, the firewall and policies within the firewall can actually stop and quarantine or warn developers of what they are bringing in. Then, and this is what we're going to spend the rest of the conversation on, is the Nexus lifecycle. Basically continuously identify risk and enforce policies and remediate vulnerabilities across the software development lifecycle. Nexus lifecycle integrates with your build tools, with your development tools, ensuring that at any given time policies are enforced that ensures the quality of your open source components. We also have the Nexus Auditor that essentially examines open source components within production applications. And finally, the Nexus Repository, our basic tool, which I think most of you have heard of, that manages libraries and artifacts, third-party libraries and artifacts across the SDLC. So combining the two, you could use the Nexus Repository to manage your artifacts and build artifacts, and with Nexus Firewall and Nexus Lifecycle to control the risk of open source components entering and being utilized throughout the software development lifecycle. And this is what we're going to be demoing shortly. This is all going to be powered by our Nexus Intelligence, the largest and the most accurate source of vulnerabilities, license data, and architectural data on open source components. Very vast trove of data that is managed by over 70 world-class researchers who are continuously looking at various projects, various ecosystems, identifying vulnerabilities and updating these vulnerabilities for our customers. This is not, our data is not driven just by public information that is available. There is a lot of curated data out there, and this is why we have the best source of intelligence. With Nexus, some of the biggest breaches that occurred in the past year wouldn't have occurred, and some of few documented facts here that we can talk about. In the case of Equifax, for example, healthy struct libraries was assembled in the production web app, so this was a thing that everybody probably uses. In mid-2017, Apache disclosed a CVE, the 5638, that essentially highlighted the vulnerability within Struts2. Within the same day, updates and the Nexus Intelligence provided visibility to all our customers with rapid path to remediation. So if you had, and many of our customers who had our solution running would have immediately got that intelligence, immediately got that notification, immediately made aware that there is now a new risk in their applications, and that risk would have been mitigated. That's the issue that occurred, and that's what contributed to the Equifax breach. Recently Equifax even came out, and Bryson Cole, our Chief Technology Officer, just recently, when we recently also announced this in a press release, as a key element of our transformation is modernizing how we build and deliver software applications so that security is built in from the start. A part of this, we trust Sonatype's Nexus platform to provide insight, visibility, and automated governance. In addition to that, is that Equifax, after that breach, went through an exhaustive research and proof of concept to sort of evaluate all the different tools. This is a very large organization with thousands of applications, thousands of developers selecting the Sonatype solution and platform. Another sort of thing that we would like to highlight here is Mary Lou, Director of Security Program Management at Salesforce. She highlights that the implementation of the Nexus platform, again, a very large organization, is very agile, continuous release, thousands of developers. She highlights the fact that our implementation of Nexus has been so impactful. Developers say it's the best project to ever come out of the security group, and I think this pretty much says it all. The Fannie Mae, a very large organization, that in the United States, a financial organization that had to sort of reinvent itself in the last few years, talks openly about creating automated controls, have improved the developer productivity by 28% and reduced cost by 30%. I will stop right now, and I'll hand over to Cameron, who will go through a presentation of the Nexus Lifecycle product. As I said, put your questions in the chat or drop us an email also if you want to. We'll go through the questions later. Thank you. Cameron, over to you.
Thanks, Ammar. Just going to share my screen. Okay, is that showing up okay? I've just got my clips there. So just sort of echoing what Ammar was talking about there, one of the things we've done at Sonatype is we've built the capability for teams to see the open source libraries that they're using and get this visibility on day one. This is the Eclipse plugin that we have. This is showing me here on the left all of the components that are in my release. So this is the starting point of the bill of materials. And the reason why we like to start in the IDE is because at the end of the day, the developers are the people who have to actually fix these vulnerabilities. So this is showing me all of my libraries, and these are being ranked here from most vulnerable to least vulnerable. So these red ones here have known critical vulnerabilities. These orange ones here have medium level vulnerabilities. And these blue ones here are okay. These are good open source. And this is what you want to see. You want to see as much of this sort of light blue as you can. Because that's the whole idea of using open source, is you get the functionality without the risks. And the whole idea of what you want to start doing with your DevSecOps pipeline is reducing the risks associated with these open source libraries. They are very good. They deliver a lot of functionality, but they also deliver a lot of risk. And one of the main reasons why they deliver risk is because, as Ammar pointed out, 68% of attacks last year were actually targeting known vulnerabilities in the application layer. And the reason why attackers have actually been using that attack vector recently is because there's a lot of opportunity for them. It's a very easy low-hanging fruit for an attacker to target a framework. Firstly, you can find a framework on the internet using Google searches. These frameworks have signatures that are easy to find. And secondly, the vulnerabilities are published. So what happens is when a vulnerability is announced, there's often an exploit available within hours to target it. This library here that I'm showing you is called Commons Collections. And this is version 3.2.1 of that library. We show you that version information. We also show you the licensing information here, if that's important to you. This is Apache 2, which is a relatively liberal license. But then we have this highest policy threat 9 with 3 policies. And one of the real powers of the Sonatype toolset is the ability to set policy that's relevant to your organization. And I'll show you some of that in a moment. But for example, one of our banking customers in Singapore, what they wanted to do with their implementation was prioritize the top 30 applications that they cared about, because they had literally thousands of applications that had potential vulnerabilities, but they only had the resources to deal with a limited number of them at a time. So the policy engine allows you to prioritize your remediation onto the applications that you care about. The next one here is the CVSS score. That's the Common Vulnerability Scoring System. That's a standard way of scoring vulnerabilities. 9 is very high, 10 is the highest. So just to give you an idea, Heartbleed was a 5. So this is a particularly high vulnerability, in fact, this particular library. And interestingly enough, with Commons collections is, I've traveled all around Asia with Sonatype over the last 2 or 3 years, and almost every customer that I've spoken to and worked with that is doing any sort of Java work is actually using this library. Pretty much everyone uses Commons collections, and interestingly enough, almost all of them are using this version, 3.2.1, which is actually known to be vulnerable. And it's been vulnerable for a while as well, and that's also interesting. So, what we're seeing here, catalog 10 years ago, that's telling you that this particular version is 10 years old. Exact here, match state exact, is telling you that the hashes that we calculate match. And that's also unique to Sonatype. We use a hash-based algorithm to reduce false positives. The idea of the hash is that we take a hash of the library on your system and we match that to a hash that we have at Sonatype. And if the hashes match, then we know it's an exact match, and we know that the version that you're using is identical to the version that Sonatype is catalogued. And identification source is Sonatype. That means we've identified it. And finally, this category. This category is something that's also unique to Sonatype. It's a new capability that we've added recently. And what we're doing is we're categorizing every single library that we can and putting them into different buckets. And this particular library is a programming language utility, but what that's going to be used for in the future is you can answer this sort of question. Someone might come to you and say, okay, I'm using this vulnerable version of this library. Is there a better library in this particular category? Is there something that everybody else is working on now and they're no longer working on this other library? Tell us that. And at Sonatype, because we run Maven Central, we're actually able to build this capability for you. And what we're actually going to be delivering is this intelligence around the library, so you can then answer that question about the quality of each of the libraries that you're using, not just their known security issues. And so this idea of improving the quality of your code, improving your sort of software supply chain by improving the parts that you use, is a really important sort of initiative that we're working on. On the right here, we have the history of Commons collections. So what I'm showing you here is this version 3.2.1 is this version here. This vertical slice is the current version, and each one of these vertical slices is another version. And this one here has this red square underneath. This is saying that it's a known security issue, critical. But if you look to the right, there's this newer version here, 3.2.2. And this version here has no known security issues. So the idea is that you can actually upgrade to that library, to that version, and remove the vulnerability very easily. And if I click on that, I can hit this button, which is called Migrate. And what that does is that actually edits my POM file for me and updates the project. And now that vulnerability is gone. So it's very, very easy to remediate in the IDE. And it's much cheaper for you to remediate here. So our philosophy at Sonatype is to give the tools to the developers so they can actually make informed decisions about the libraries they're using and improve the security posture of their applications over time. Let's just quickly have another look at another library here. I'm going to have a look at Struts2, for example. This is the one that Ammar was mentioning. Struts2 is a web framework. It's the third most popular web framework in Java. After Spring, it's very, very common, and was the library that was used by Equifax to write some of their website, and it was the library that was targeted by hackers in 2017. Interestingly enough, this exact same library was used to steal data from the Indian identification system, Aadhaar, as well. Exactly the same library, exactly the same exploit. And what we're seeing is hackers are taking advantage of these libraries and targeting these frameworks because it's just so rich for them as a way of attacking hundreds and hundreds, if not thousands or millions of sites, all in one automated process. Now let's have a look here. There's a few newer versions, and let's have a look at this one here, 2.5.20. That was released a month ago. And so this is the other thing that we help you with is if you are trying to manage this manually, it's very, very difficult, if not impossible, because there's so many libraries being used, there's so many dependencies. Without an automated tool to identify what you have in your system and what you're using, you're really going to struggle to remediate it and improve your security. So what we want to do is give you this tool. It's part of the life cycle. It's embedded in the IDE, and then the developers can see what they're using and fix them on day one, where it's hundreds of times cheaper than to fix it later in the project. And this is just a starting point. This is something that we give developers. They're not forced to use it, but it's a good idea to give it to them because they're going to be fixing it. But we can also enforce the security posture of the organization through our integration with Jenkins and other tools. And what I'm going to do is I'm going to show you how you can implement that using the policy engine and using the build tool Jenkins, just as an example. But we work with lots of tools. We integrate with most modern CI/CD pipelines. And part of what we do also at Sonatype is we help you. So we have a lot of experience in DevSecOps, working with these organizations like Salesforce and now Equifax and others to improve their DevSecOps pipeline. If you want assistance with, we have the ability to give you guidance and reference architectures, for example, that we've developed over the years and we've collected with our customers. The starting point of doing the enforcement and the remediation is the lifecycle server here. We call it the Nexus IQ server, and it's a policy engine that runs on your premise. And what it does is it is used by the tools to scan your applications and to enforce policy, and also to integrate with all of your other tools, your Jenkins and so on. The simplest use case, you can actually just simply upload an application into the server. So I can simply grab it here and say evaluate binary. This is the simplest use case of the whole tool set. What I'm going to do here is just scan an application very, very quickly. Grab a component. Get this one. And what it does is it takes a fingerprint, which is a SHA-1 hash of the components. Your source code does not get sent to our servers. We don't ever see your source code. What's actually happening is the SHA-1 hash is calculated locally, and then the SHA-1 hash is matched against the list of SHA-1 hashes that we've ingested at Sonatype. We have literally millions of libraries that we've catalogued over the years and millions of vulnerabilities. So let's view the report. That's it. That's just evaluating one component very, very quickly. We can see here that this particular library, Xylan, has a known vulnerability in 2.40. There's some fixes out here. We can view the data around this particular vulnerability. There's actually 3 known vulnerabilities. 2 of them have public CVEs, and one of them has a Sonatype code. That Sonatype code is used by our researchers to catalog vulnerabilities that they find that have not been entered into the CVE system. Interestingly enough, a lot of people have heard of CVEs, and they come from a database called the National Vulnerability Database. But what is not commonly known is that system is actually a voluntary system. There's no enforcement, and there's no rule to say that you have to raise a CVE. And so what a lot of projects are doing now, and I'll show you this, especially in JavaScript, is they do not create CVEs. They do not log their vulnerabilities. What they're typically doing is they're fixing their vulnerabilities in GitHub, for example, and then they are just moving on. They don't actually record a CVE. And so if you're just tracking CVEs, you're going to miss that. So what I'm going to do is I'm going to show you how to set up a policy that will actually look at these sorts of issues and enforce the rules that you have about security at your organization. So what we do is when we set up a policy, you have here on the left an organizational hierarchy, and the organizational hierarchy is you have your whole organization, you have your different teams, and you have your different applications. On the right here, we have these different application categories, and what that's useful for is that allows you to prioritize the risk assessment that you're doing. So distributed applications hosted in internal, sort of built-in categories that we give you, but you can create your own, but that's to handle risk associated with mobile phone applications or SaaS products or APIs and things like that that you might be producing. Now let's add a policy. And what I'm going to do is I'm going to check for security issues. And what we do is we actually say, okay, the threat level here is from 0 to 10. I'm going to make this a level 10. We have this idea of grandfathering. I'm going to skip over that for today, but just sort of a quick sort of explanation of that. The idea of grandfathering is that when you onboard your applications, you can actually tell the system to grandfather the risks in your legacy applications. And the reason why you might want to do that is that you don't necessarily want to get alerted to all the vulnerabilities that you have in all your old applications. You want to see them, but you don't want to stop the build. You don't want to stop developers from producing software. But what you can say is, we're not going to allow the software to get any worse. And that's what the grandfathering allows you to do. We're going to check the CVSS score. And these are the different criteria and conditions that we support, the coordinates and the age and so on. But I'm going to be looking at the security severity here. So this is checking the CVSS score. And what I'm saying here is, if there's a known vulnerability in the library, then I'm going to actually stop the build. And down here is where we have these actions. And this is where we can actually start interacting with your build system in Jenkins and so on. And reading from left to right, this is mapping to the software development lifecycle. So the proxy is for integration with Nexus repos. So that allows you to firewall components. It allows you to block components from even coming into your pipeline. This is very popular with a lot of our banking and government customers because they want to make sure that no one downloads no vulnerable libraries in the first place and pollute the software supply chain. I'm just going to skip that one for now, but what I'm going to do is I'm going to say, I'm going to do a warning here, and then I'm going to do a failure here. So what that does is I'm basically saying from left to right, I'm going to allow the developers to keep coding, but when they start doing their builds and promotion, I'm going to warn them that there's a known vulnerability in their software. But I'm going to fail the release, and what that means is that I'm not going to allow them to push that into production if there's a known vulnerability. And then I'm going to create a notification. And then I'm going to email myself. And then also I'm going to turn on Jira. And so the idea of this is that we can actually raise a Jira ticket. This is a built-in integration that we have that will integrate with Jira and create a ticket in the system if there's a known vulnerability has been added to the release. And finally, we have this continuous monitoring. This is also a really powerful feature that we have. This allows you to check applications every day looking for zero-day vulnerabilities. So what that means is that the system will automatically scan all your existing applications each day. Okay, that policy is created. Let's kick off some builds. So I've got my Jenkins here. And what I'm going to do is I'm actually going to kick off a whole bunch of builds in parallel.
Cameron, as you are waiting for the results to come up, there's a question here about the languages that we support. Is it just Java and JavaScript?
Okay, so whilst our background is in Java, we've added support for JavaScript, Python, Ruby, Yum, .NET. As a matter of fact, we helped Microsoft build their NuGet system, which is their .NET capability for package management. We also have support for PHP and C and C++, and basically 95% of modern languages.
Another quick question: the plugin that you used for Eclipse.
Yeah.
If you could just basically clarify that that's part of the...
Yeah. So the question there is the plugin for Eclipse. That's part of your license for Lifecycle. So when you get Lifecycle, our flagship product, that gives you the plugin. All the plugins that I'm showing you are part of Lifecycle. So the plugin for Eclipse will be part of that, and also this Jenkins plugin. So as a matter of fact, while I've been speaking, all of those scans have actually finished. So as you can see, they've taken 30 seconds, on average each, very, very fast. The scans have actually warned here, this is the orange, but failed here at these later stages. The release and operate stage have failed. That's because I told it to do that. And if we have a look at that build, you actually get this application composition report. This is a bill of materials that's generated for each release. And I'm just going to have a quick look at the output here in the console so you can see what happened underneath the covers. All of these components, all of these jars were found inside the release. Also JavaScript. Anything that's actually inside the release, so this is the web application, so it's got Java and JavaScript in fact, have all been picked up and automatically. This is the policy that we told it to fire. And then the report is here at the bottom. I'm just going to scroll down to the bottom. Almost there. Here is the report. And so this is the bill of materials that's generated for each application. So this is showing you that there's actually, this particular application is 100% open source. These are the security issues, the licensing issues associated with that release. When you click on the policy violations tab here, this is actually giving you a breakdown of every single library. So this is the bill of materials. You can print this off and deliver this to your stakeholders or make this part of your release documentation. We've got these security issues here. So I'm going to show you this commons collections that we've been talking about. This is the same information that we had in the IDE, but it's now available in this dashboard. And then also these are the vulnerabilities associated with that one there. So we have this sort of deep research that we add. This is the vulnerability information that's added by our security research team. They don't just rely on the public information. That's just a source of information for them, but they also enhance the data. They explain what the vulnerability is, they explain how to identify it, how to detect it, and also how to remediate it. This is the remediation advice. So for this particular one here, we say we recommend upgrading to a version of this component that is not vulnerable. But there's actually a potential workaround as well, and we tell you that. And finally, we have here the root cause. This is the actual underlying class inside of the code that caused the vulnerability. And we have these advisories here as well. So this is our research. This is the evidence that you can show your developers if they question why is this vulnerable. You can show them how this was calculated. So show it's not a false positive. And finally, we've also added this CVSS vector data as well. So this is something that is important to security people, explaining how that particular vector is exploited. Now, just finally, I'm going to show you some quick dashboarding information, and then I'll hand back to Ammar. So this dashboard here, this is actually showing you all of the scans that have happened in the last 30 days. So these are the scans we just did a few minutes ago. All of the new vulnerabilities get reported here immediately, whether they're coming from Jenkins or whatever tool you're using. You get to see it here in the dashboard, and you can export this out if you want to send it to a BI system or a reporting system. This is the components view here. This is actually telling you all the most vulnerable components, but also it sort of answers that question. Someone might come to you and say, "Oh, I just heard that Spring is vulnerable. Are we using Spring anywhere?" Well, yeah, we are. This is the Spring framework. We can click on this number 16, and straight away it just zeroes in on those 16 applications in the organization that are using that vulnerable framework. So you can start the remediation very quickly. Rather than having to email everybody in the company, you can just contact these 16 teams and say, okay, you're using Spring, the vulnerability was just announced, let's start the patching effort. And the whole idea of what we're doing here, if we sort of step back, is to reduce the time it takes for you to patch. The time it takes for you to release a security patch is really important now. As the attackers are attacking you very quickly, you want to try and reduce your window that they can attack you by patching as soon as you know about it. And that's what this DevSecOps movement allows you to do. And that's what our tools have actually, the capability they've created is allowing you to patch very quickly now. Find the vulnerability, find the project that's using it, and patch it and release it, and do that as quickly as possible. And that's how you can actually improve your security posture moving forward. I'm going to hand back to Ammar now.
Okay, quickly just to take care of some questions that just popped up. Apart from Jenkins, do we integrate with other tools, and specifically Go?
Yeah. So we have lots of integrations. We have integrations with Bamboo. We have integrations with other build tools. We have integration with other repository managers. We have also a REST API and a command line interface. So you can always create your own integrations as well, and we can help you with that. So that's very flexible.
Okay. Is there support for other IDEs and build system, example, Visual Studios and CMake? So I think you've answered that.
Yeah, so we have a native integration for Visual Studio on premise. We also have a native integration for IntelliJ, and we can also integrate with any IDE that's built off IntelliJ as well. So a lot of people are using, things like Android Studio and other IDEs like that. If they're built on top of IntelliJ, then we work with that automatically.
Okay. The other question is the Nexus repository part of the Nexus lifecycle that you don't?
Yeah, Nexus repository is that part of Nexus lifecycle. No, they're independent of each other, and they work seamlessly and separately. The lifecycle is the product that I've been demoing here that integrates with your IDE, with your Visual Studios, and so on, and also your Jenkins and your build tools. The repository works independently of lifecycle.
Okay. Another question here. If we, I'll take that. If we make Nexus IQ Server as part of the lifecycle, do you vouch for the absence of? Do you then assume any liability in case system failed to flag vulnerabilities and that impacted us downstream? Well, this sounds like a legal question, and I'm happy to have, the liabilities and this sort of thing are spelled out in our license agreement, but this is being used by the largest banks in the world, organizations such as Salesforce, organizations such as Equifax and others, and so we're taking they're relying on us and the intelligence we provide, and we're happy to sort of be in there with those guys. But from a legal perspective, I'll have to defer and answer that question by talking to our legal guys. You didn't answer about CMake. Do you have a command integration for Linux builds? Do you have a command line integration for Linux builds? And you did not answer about CMake. Yeah, so question there is, do we have a command line integration for Linux builds, and do we integrate with CMake? The answer is yes and yes. So the command line integration that we have works actually works in any operating system that has a Java virtual machine. The only requirement that we have is that you have the Java virtual machine 8 or above installed. And yes, we work with CMake for scanning C projects. I don't see any other questions. If there is anything else, please drop us a note. I will actually put my email address in the chat, and happy to take any questions from you folks, or any further sort of detail or explanation. And if there are no answers, I thank all of you for attending the webinar, and I look forward to working with you and chatting with you some more. Again, a recording will be sent to you guys later on. Thank you very much.